So a magic square is an arrangement of numbers in the shape of a square. Okay, some of you may have experience with magic squares already. Okay, so you know that it is called a magic square because the sum of each vertical column, the sum of each row and each diagonal, they are all the same, they are all equal. That is why it's called a magic square. Okay, so let's look at some of the characteristics of magic squares. Okay, we know that the sum of all the numbers on each row, each column and each diagonal are the same. Okay, this is so this is the first characteristics of magic squares. Okay, and number two, the order of a magic square tells how many rows or column it has. Okay, so a square with 3 rows and 3 columns is order 3. Order 3, sometimes we say the magic square is 3 by 3. Okay, 3 by 3 means this is order 3. Okay, it has 3 rows and 3 columns like this. Okay, I'm not going to draw that. Okay, it has 3 rows and 3 columns. Huh? Okay, so order 4 will mean that it has 4 rows and 4 columns. Okay, and so on. Okay, a square consisting of consecutive numbers starting with 1 is sometimes known as a normal magic square. Okay, as a normal magic square. That means if you have numbers like this starting from 1, say like this, example, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. These are called consecutive numbers, okay, because after 2 is 3, after 3 is 4, after 4 is 5. So these are consecutive numbers. So if you have a set of numbers starting from 1, say until any number here, then this, and if you can arrange these numbers in a magic square, then it is known as a normal magic square. So all normal magic squares starts with 1 and they are consecutive numbers. Okay. So if your normal magic square has order 3, that means if the order is 3, that means the numbers start from, this is only for normal magic square, so the numbers start from 1 until 3 square, which is 9. So if you have order 4, that means the numbers start from 1 until 4 square, which is 16. So you have 16 numbers which you are going to order 4 means 4 by 4. So 4 by 4 means there are 16 boxes and you have 16 numbers here. So order 5 will be numbers start from 1 until 5 square. This is the 5 times 5 magic square. So we have 25 boxes here. So order n will be 1 until n square. So this is the n by n magic square. Okay? So far so good?
Okay.
So a normal magic square order, okay? Order n contains integers 1 until n square, okay? Arranged such that the sum of the numbers in any row, any column and main diagonal is the same. The sum for a normal magic square is given by this formula, okay? N times n square plus 1 over 2. This is the sum of all the numbers in each row, each column and each diagonal for a normal magic square. Okay? This sum is also known as the magic constant. Okay? This sum is also known as the magic constant. Okay? So if your numbers are all in consecutive order starting from 1, you can use this formula to find the sum in each row, in each column or in each diagonal. Okay? But if you have a sequence of numbers starting with A, say starting with integer A, and with entries in an increasing arithmetic series. Arithmetic series means the difference you plus, say like 2, 4, say 2, 4, 6, 8. The difference here is 2, 2. You plus 2, plus 2, plus 2. This arithmetic series. It can be 3, 6, 9. Okay, you plus 3, you plus 3. Okay. So if you have an arithmetic series, an increasing arithmetic series, the first number is A, and the difference between the terms, you see the difference is the same. The difference between the terms is D, then the sum in each row, in each column, or each diagonal is given by this formula. Or, I have space here, okay? Or we say that the sum is equals to half n 2a plus d n square minus 1. Okay, so this is the formula. This sum is also known as the magic constant. Okay, so n here is the order, a is the first integer, d is the difference. So using this formula, you can find the sum in each row or each column or each diagonal. Why do we need to find this sum? We need to know this sum before we can actually arrange the numbers in the magic square. Okay, so these are some of the characteristics of the magic square. Okay, just for you to know, there are three types of magic squares. The first magic square is singly even order magic squares, or sometimes it is known as single even order magic squares. The second type of magic square is doubly even order magic squares. And the third type is odd magic squares. Okay, so today we are going to look at these three types of magic squares, how to fill these three types of magic squares. Okay, there are some known ways to fill these magic squares. Actually, there are many ways of filling magic squares. Okay, it's just your preference which way that you want to use. Okay, so let's look at the next slide. Okay, so we're going to start from the odd magic square because it's much easier than the even magic squares. Odd magic square, how to construct an odd magic square. Okay, so before that, we're just going to look at some examples. Okay, first example, supposing we had numbers like this, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay. Okay, so we have 9 numbers like this. Okay, so what is the magic constant for these numbers?
3.
How do we find the magic constant? What is the formula? N times n square plus 1 over 2. Why are we using this formula? Because the first term is 1 and they are all consecutive numbers. So that is why we are using this formula. So what is n here now? N is, okay, if we have 9 numbers, we are going to put it in a square. Sorry, we're going to put it in a square that is 9 boxes like this, right? So this is 3 here and 3 here. This is a 3 by 3 magic square. So the order here is 3, right? Order is 3. So which means your n is 3. N represents the order. So if we put in the values is 3 square plus 1 over 2. How much is this? 3 times 3, 9 plus 1, 10. 10 times 3, 30. 30 divided by 2, 15. What does this tell you? What does this mean, 15? 15 means the sum in each row must give you 15. The sum in each column must give you 15. The sum in each diagonal must give you 15. Okay, so let me try and put in these numbers into this square for you. Okay, oops, sorry. Okay, so now let's calculate each row. How much is this? 8 plus 1 plus 6 is 15. 3 plus 7 plus 5. 3 plus 7 plus 5 is 15. 9 plus 2, 11 plus 4, 15. How about each column? 8, 3 and 4, 15. 1, 5, 9, 15. 6, 7 and 2, 15. This diagonal, 6 plus 5 plus 4 is 15. This diagonal, 8 plus 5 plus 2 also 15. Okay, so the sum of each row, each column and diagonals are all 15. Okay, this magic square is order 3, which means it is an odd magic square. Okay? Okay so far?
Okay.
Okay.
Yes, madam.
Okay, let's try one more. Okay, let's try one more magic square. Okay? Okay, let's try another example here. Say I have numbers like this. 19, 31, 43, 55, 67, 79, 91, 103, 115. I'm using the smallest magic odd number magic square, which is order 3, 3 by 3 magic square. Okay, so I have 9 numbers here. I want to arrange these 9 numbers into this magic square. So first, before I can do that, I have to calculate the magic constant. So what is the magic constant in this case? Which formula am I going to use?
1/2.
1/2.
Yes, correct. 1 over 2 n into 2a plus d n square
N
minus
square.
1. So what is my n here? N? 9 numbers means this, 9 numbers means is 3 square. So n is 3. So this is 3 times 3. So it's 3. N is 3. A is the first integer. What is A?
19.
19, yes. D is the difference between the numbers. 31 minus 19, 12. 43 minus 31 is 12. So you must check. If you find the difference for all the numbers here, you will find that it is 12.
12.
So D is 12. So D is 12. Okay, now we put into our formula. So our magic constant is n is 3 over 2. So 2 times 19 plus 12 d n squared. N squared is 3 square minus 1. Okay, so this is 3 over 2. 19 times 2, 38 plus 3 times 3, 9 minus 1 is 8. 12 times 8, 96. So what do we get here? 3 over 2 times by, this is 134. So 201. Okay, so which means this is our magic constant. Okay, it means that the sum of all the numbers in each row, each column and the diagonal must give us 201. Okay, so how are we going to, so let's try. Okay, I'm just going to try this. I'll show you the formula afterwards. So it looks like very simple. Okay, if you see me doing this, so you should get an idea how to do it later. Okay. Okay, now can you check for me? Am I correct or not? The first row, what is the total in the first row? 103 plus 19 plus 79 gives you?
201.
Alright. Second, you must check everything. This second row, also 201?
Yes.
Yes.
Yes. Okay, you keep checking and tell me if there's anything that's wrong here. The diagonal also will give you 201, and this diagonal also has to give you
201.
201. Okay, so this is our odd number magic square. So this odd number, the way we fill this, the way I fill this magic square is I use the Siamese method. This Siamese method was first introduced by this person. Okay, Simon de la Lauber or something like that. So he was the first person who actually introduced this Siamese method. He went to Siam at that time, and he actually learned this method. So he was one who published this method first. Okay, it's called the Siamese method, which I'm going to show you very shortly. Okay. Okay, let's do another example. Okay, you give me one set of numbers. One set of numbers with the same difference. Any number, any 9 numbers. Anybody want to suggest a number?
5.
5. Okay. Next number. Give me 9 numbers
Okay.
with the same difference. Arithmetic series.
5, 10,
Okay. 5, 10, 15, 20, 25. How many already? 25, 30, 35, 40, 45.
yes.
Correct? 9 numbers. So we want to put this in our square here. Okay. Okay. So before that, we calculate our magic constant. What's our magic constant? Is 1/2. What is our n here?
5.
N?
3.
3. Yes, n is 3 because 9 numbers we're going to put into this box here. So this is a 3 times 3. So n is 3. Okay. And what is our a?
5.
A is 5 plus d is
5. 14.
5. So this is 3 square minus 1. Okay. So this is 3/2 into 5 times 2, 10 plus. This is 40, right? 9
Yes.
minus 1, 8 times 5, 40. So 3/2 times 50, 25. How much is this?
75.
75. Okay. So that means our total must be 75. Okay. So you watch what I'm doing. Okay. So I'm going to start from here. 5. I'm going to put this in the first row center. I'm going to put the first number. Okay. Then each time I'm going to move diagonally up and to the right. Okay, up and to the right. So from here, I am going to move from 5 here. I'm going to move up and diagonally here. So I'm supposed to be here, but it's already outside the box. If it's outside the box, then I have to go to the end of the same column or row. So I have to come here. Okay, so I'm going to put the next number here. This is 10. Now from here, I'm going to move diagonally up and to the right. Okay, from here up and to the right. I'm also outside the box. Because I'm outside the box, I'm going to go to the end of that row here. And what is the next number is 15. So I'm going to put 15 here. Now, again, I'm going to go up and to the right. Okay, I'm going to go up and to the right, but this box is already filled. If the box is already filled, then I have to put the number below the previous number here. So this is 20. Okay. From 20, I'm going to go up and to the right here. So the next number will be 25. Okay. Then I'm going to go up and to the right. So the next number is 30. Okay. So from here, if I go up, it's going outside the box and there's nothing here and here. So I'm going to put the next number below this number here. 35. 35. Okay. And from 35, I'm going to go up and to the right. Nothing here. So I'm going to go to the end of the first same row. So the next number there is 40. Okay. From here, I'm going to go up to the right. Nothing there. So come straight down to the end of the column. So the next number there will be 45. So now you check, is it correct or not? Okay, let's check. 40 plus 30 plus 5 is 75. 30, 40, 50, 60, 75. 40, 50, 60, 75. This way, 40, 50, 60, 75, 75, 30, 60, 75. Diagonal 30, 40, 50, 60, 75. This diagonal 40, 50, 60, 75 also. Correct? So our sum is all equal. All the rows, all the columns, and all the diagonals equal to 75. So we have put in these 9 numbers into this 3 by 3 magic square order 3 using the Siamese method. Can you understand the method?
Yes.
Yes. Yes.
Everybody can? Okay, let's try. Okay, let's try and do one more example here, okay? Okay, I'm going to give you a set of numbers. I want you to try, okay? You must be able to do this within 5 minutes if you understand the Siamese method, okay? Okay, put these numbers in the magic square below using the Siamese method. So first step is calculate your magic constant.
I got 24.
So what is your magic constant?
24. Is it?
How much?
24?
No. What is your
No.
A?
5.
39.
Yes, 39. Because your order, because we are only using 9 numbers here. So your order is 3, yeah? Your first integer is 5. Your difference here is 2. Difference is 2. Plus 2 times 3 square minus 1. So this will give you 39. Okay? So you know that each sum in each row, each diagonal is 39. Now put in the numbers very fast. Ken? Anyone has done it? Okay, tell me what is the
Yes,
first
yes.
number here? First number in the first box,
19.
20.
19. Second box here,
5.
5.
5. And then,
15.
how much?
50.
15. Okay, here,
9.
9.
9.
13.
How much?
13.
13.
13, yes. Here,
17.
17.
17.
11.
11.
11.
21.
21.
7.
7. Okay, so very good. This is done. Very good. Huh? So everybody got this?
Yeah.
Did everybody get this?
Yes.
Madam, can I ask a question?
Yes.
Must the first
Yeah,
integer
please.
number be
Go ahead.
in the middle top?
Integer we always put in the center top row. We start from here. This is your starting place.
Oh,
Okay. So
we
when you
cannot put it
start,
randomly.
yes. So you put the first integer here, then you start from here. You go up, nothing there. So come down to the same column. Put your second number. From here, you go up and to the right, nothing here. So go to the end of the same row. Okay. From here, you want to go up, but already something here. So if there's something here, you must put below this earlier number. So you put it here. Okay. From here, you go up, right, then up, right. From here, you go outside, nothing here, nothing here. So you put below the previous number. From here, you go up right, go right to the end here. Put the number, go up right, it's nothing here, so come straight down, put it here. Okay? Okay, let's challenge ourselves a little bit, okay? Okay, never mind. Okay, so this is so we are still doing odd number magic squares, odd magic squares, okay? So what is the order of this magic square here?
5.
5.
Yes, order 5, so it's 5 times 5, okay? So if it's order 5, let's say we want to put in numbers 1 up till 25, okay? So this is a normal magic square, right? Normal magic. So what will the magic constant be?
And
N square plus 1 over 2, right? So n is 5, so 5 squared, but how much is it?
65.
Yes, 65, so we must get each column and each row and each diagonal to a total of 65. So let's try, okay? Let's try. I think you also can do this very fast. Where do we put the first number? Here, right? Okay, you do first. You try first. I'm sure you can do this very fast. Same method, Siamese method. Keep on following the same method. You will be able to fill this very quickly. You try first, okay? Then I'll give you the answer. So you have the answer? Have you all done?
Yes.
Anybody managed to do?
Yes.
Yes, okay. If you have managed to do, you just check your answer with me, okay? So let me start here, okay? We're going to start the center here with our number 1. So from here, go up, nothing, come straight down here, which is 2, correct? From 2, go to the right up. We always move towards the right, up, okay, this way, diagonal here. So this is 2, 3. And after 3, we go out here, it's out here. So we move right to the end here and put 4. 4 go up, 5. 5 go up, there's already a number here. So we do put the next number under 5, 6. So 7 go up, 8. Go up, you're outside, so come straight down here. This is 9. 9 go out here, so you come straight here, 9. This is 10. 10, you go up, there's already a number here. So you put your number below 10, 11. 11, 12, 13, 14, 15. After 15, you go up. You cannot go either side, so you put it below 15. So 16 is here. 16 go up, is outside here. So you go right to the end here, 17. Okay. 17 go up, outside. So come right to the end here, 18. 18 go diagonally upwards, 19, 20. Here you go here. There's already a number here. So you put it under 20, 21. 21 go here, 22. 22 go out, go straight to the end here, 23. 23 go up, 24. 24 go out, come straight to the end, 25. Okay?
Yes.
Okay,
Okay.
so do you find this interesting or not?
Yes.
Yes, so later you
Very
can play with your
interesting.
friends. You can use any odd numbers, okay? Any any magic square with any order, odd number order, and you can put in the numbers. If the numbers are normal magic square, if they're starting with 1, very easy for you to do. Even if they don't start with 1, also very easy, okay? So once you have put in, you make sure you check the sum in each row, each column, in each diagonal by calculating the magic constant, okay? So we have finished with odd magic squares.
Madam,
Yes.